Good morning, students, all of you. The last class we started atomic mass we did. After atomic mass, I told you average atomic mass. See, what is average atomic mass? We abbreviate with AAM. And yesterday I told you if you see hydrogen in the periodic table, it will be mentioned as hydrogen as 1.008 U. And if you see chlorine, chlorine will be mentioned as 35.5 U. And yesterday we discussed that why we are getting fractions like this 0.008 or zero point 0.5. It is due to presence of isotopes we discussed. Then student, what are isotopes? Atoms of the same element having same atomic number but different mass number. So for example, you take hydrogen, every element will have its own isotopes. For example, if I take hydrogen, hydrogen has protium, this is deuterium, and this is tritium. Tritium is a radioactive element. So these are the isotopes of hydrogen. And along with this, I told you yesterday, there will be, you have to consider percentage abundance. Percentage abundance of an element we have to consider. Like this, every element will have its own isotope. Suppose if you take chlorine, chlorine has two isotopes. What are those? Chlorine 1735 and chlorine 1737. So like this, which element will have highest number of isotopes in the entire periodic table would have been asked. Later we study periodic table. Tin has maximum of 10 isotopes. So here tin has maximum of 10 isotopes. This we study later in periodic table in the main chapter. So tin has maximum of 10 isotopes. Then how do we get average atomic mass? In order to get average atomic mass, yesterday we discussed that. If those who are in the last class, summation of percentage abundance into atomic mass upon this by summation of percentage abundance. This we already discussed yesterday. So once again I am continuing for continuity. So this is the relation yesterday we wrote, and I think one problem we did on this. This is important in main JEE mains as well as in NEET. They are asking questions on average atomic mass. So you know, no percentage abundance, average atomic mass. How do we get? We have to consider percentage abundance into atomic mass by summation of total abundance. This all of you understood. Yesterday we discussed this. Once again I repeated this as for continuity sake. Clear? And yesterday I given one problem. If you remember, chlorine has two isotopes I mentioned yesterday. What are the two isotopes? One of chlorine 1735 and another of chlorine 1737. Correct? And for this yesterday I given abundance of this. This abundance is 75% and abundance of this is 25%. So in the problem they will give the percentage abundance and atomic mass. See, this is abundance of the particular element and this is the abundance for the second element. Then how do we get average atomic mass? See, in order to get average atomic mass, yesterday we did this. This atomic mass is 35. So 35 into 75 is the percentage abundance plus 37 into 25 by total abundance is how much? 100. Correct. Yesterday we did this, and when you simplify this 35, 75 is how much we got? 35 when you multiply with 75, 5 5s are 25, 3 5s are 15, 17, 5 7s are 35, 3 7s are 21 plus 3, 24. That is coming how much? 12, 5, 6, 2, 6, 2, 5. That is coming 2625 plus this multiplication of 37 with 25. 37 when you multiply with 25, 5 7s are 35, 3 5s are 15, 18, 2 7s are 14, 7. This comes how much? 12, 925. So when you add both of this and divide with 100, how much we got yesterday? This is 2625 plus 925. So when you add both of this comes 5, this is 15. Is it coming 3550? No? So this 3550, when we divide with 100, what I can cancel? 0, 0 cancel. That is 355 upon 10 comes how much? 35.5. See, do we got fraction or not? Like 0.5. Why we are getting this 0.5 means due to presence of what? isotopes. So in assertion reasoning question, they may ask you average atomic mass will have fractional values that can be given as assertion. The reason is what? It is why it is getting fraction. It is due to presence of what? Isotopes. So in exam point of view, they give assertion reasoning, conceptual question they can ask, or even numerical they can ask. Clear for all? This is how we find percentage abundance, that is average atomic mass. Clear for all? And now write one more question. See, an element is there, boron. Boron has two isotopes. What are the two isotopes? B510 and B511. Copy this. So in this boron there are two isotopes, B510, B511. And here see in the problem, average atomic mass I am giving to you 10.8 U. So what is the average atomic mass? 10.8 U given. And I want percentage abundance of B511. Find the percentage abundance of B511. Now see students, yesterday in order to find the percentage abundance of this, we don't know, no? So assume that as x, or one shortcut is there. What you do, draw two extremes. This is number line method. So no need of assuming x, the other as 100 minus x. This will give shortcut. See what I am doing, mass number is 10, no? On one extreme you write 10 and another extreme you write 11. Getting idea what I am saying? See, atomic mass of 10 I wrote on left side and the 11 of this I wrote with right side. Number line method. And what is the average atomic mass given? 10.8, no? So this 10.8 will be nearer to here, no? Here I am writing 10.8. Following students, this is number line method. See, now I want the percentage abundance of whom? B511 I want. So if I want the percentage abundance of B511, now see, take difference of these two. Which one? 10.8 minus 10. And here on the below you write what are the atomic masses given. One side you write 10, already we wrote, no? So another side 11. Understood what I am saying? See, percentage abundance of B511 if I want. So what you take, difference of these two you take, mean difference, which is the highest value 10.8 minus 10. Suppose if I ask you percentage abundance of B11 would have been asked. If I want B11, take difference of these two. Now I want B511, no? So B511 to get what I have to take difference of these two. If I want B10, what I have to take difference of these two you have to take. Understood what I am saying? So now see what should I take difference of, since I want B11, so take difference of these two. What is that? 10.8 minus 10 upon what? Mean difference of these two. 11 minus 10 into 100. So this comes how much, student? This is 10.8 by 1 into 100. That means how much percent we are getting? 80% is the abundance for B511. And if I want percentage abundance of B510, say, previously B511 we found, now B510 we want. So if you want B510, what you do? Take difference of other two. Understood? 11 minus 10.8. Are you getting my point? So difference of other two by mean difference of these two extremes. That is 11 minus 10 into 100. This comes how much, students? 11 minus 10.8, 0.2. So 0.2 upon 1 into 100, this is coming how much percent? 20%. So this is the shortcut by which we find abundance by knowing what? Average atomic mass. Understood? And this method is the shortcut. Instead of assuming 1, you can even do assuming this as x, what will be the abundance of this? 100 minus x. So instead of doing in this way, shortcut within easy step, we can find out the percentage abundance. Copy this. Clear for all? That means in exam, two ways they can ask. Percentage abundance, atomic mass giving, they can ask average atomic mass. Or by giving average atomic mass, they can ask you to find what? A percentage abundance. Following students, all of you. So this is important, average atomic mass. Now we go for next heading, right? Gram atomic mass. Write heading gram atomic mass. Copied everyone? Understood, no? Right. Next write heading gram atomic mass. Now see students, this gram atomic mass we also call simply as gram atom. What is the other name? Gram atom. Now what is gram atomic mass or gram atom? The mass of 1 mole of an atom. So what we define for gram atomic mass? Mass of 1 mole of atom is known as gram atomic mass. So as you know, 1 mole of any substance contain how many particles? Avogadro number of particles, no? Suppose if I ask you gram atomic mass of nitrogen, what will be your answer? 14. Instead of U, what we write? Grams we write. That means atomic mass expressed in grams is called gram atomic mass. Understood? Same way if I ask you what is the gram atomic mass of oxygen, you have to see examiner whether he is asking atomic mass. If only atomic mass would have been asked for nitrogen, I have to write 14 U. If gram atomic mass is mentioned, you have to write in option 14 gram. Same way, what is the gram atomic mass of oxygen? It will be 16 gram. Understood? So atomic mass expressed in grams is called gram atomic mass. So how I got this 14C, students? You know what is the atomic mass of nitrogen? I told you to remember the 20 elements atomic mass. Atomic mass of nitrogen, last class we discussed, it is 14 U, no? So what is U? Unified mass. And in the last class I told you 1 AMU is equal to how many grams? Remember 1 AMU. What is AMU? Atomic mass is equal to 1.66 into 10 power minus 24 grams. So I have to multiply this 14 with 1.66 into 10 power minus 24. This will be mass of what? One molecule. Mass of one atom. For 1 mole to get, what should I do? I have to multiply with Avogadro. What is the value of Avogadro? 6.023 into 10 power 23. On simplifying this, you will get the same value, but the value you get in what? 16 grams we get. So understood all of you? So here, so mass of 1 mole of atom or atomic mass expressed in grams is called gram atomic mass, or simply what we call gram atom. And remember one more important point. In exam, whenever they ask 1 gram atom is equal to 1 mole. 1 gram atom is equal to what? 1 mole. You have to keep it in mind. 1 gram atom will be equal to mass of 1 mole. So in exam they use this terminology. Gram atom is nothing but it is equal to 1 mole. Copy this. Clear for all? So saw the difference between atomic mass and gram atomic mass, no? So in the exam, atomic mass of nitrogen would have been asked, I have to write 14 U. If gram atomic mass would have been asked, I have to mention in what? 14 grams. So same way, gram atomic mass of oxygen would have been asked 16 gram. Atomic mass of oxygen mentioned 16 U we have to write. So how we got that 16 grams, 14 grams means here I mentioned. This 14 U we are multiplying with what? Mass of one atom. As you know, 1 AMU is equal to how many grams? 1.66 into 10 power minus 24. This is further multiplied with Avogadro number. That will give how many grams? 16 grams we get. And remember, 1 gram atom is equal to 1 mole. This is important later in mole concept. In NEET as well as in JEE means 1 gram atom they mention. So 1 gram atom we have to keep it in mind, it is equal to 1 mole. Okay. Now write next molecular mass. Right. Molecular mass. Just like atomic mass, what we say? Molecular mass. You remember student, I told you atomic mass means we take in standard of what we discussed, C12. So molecular mass also if we compare with C12, that means what we do in order to get molar mass, we take algebraic sum. Means we will add the atomic number of all the elements in a compound. So what we define for molecular mass, it is algebraic sum of atomic mass of all the elements in a compound. Right definition. The algebraic sum of atomic mass of all the elements in a compound. In a compound. Understood, students? So, in order to find molecular mass, what we do? We add the atomic mass of all the elements in a compound. And in the last class, I told you to remember atomic mass of 20 elements. Along with that, few elements I have given copper, zinc, silver. So, you have to remember those atomic masses. Then only we can approach mole concept. These are all the fundamentals for the mole concept. Now, see, for example, I give you few compounds, H2O. Now tell me how I get the molecular mass of H2O. I have to add algebraic sum of atomic mass. What is the atomic mass for hydrogen? 1. There are how many hydrogens? 2. So I have to add 2 into 1 plus oxygen atomic mass is how much? 16. Then what should be the answer? 18. In units of what I have to write? U. What is U? Unified mass. Simple. So copy this. So it is nothing but algebraic sum of atomic mass. How many atoms are there? 3 atoms are there. Hydrogen atomic mass is 1 and oxygen atomic mass is 16. So 2 of 1 plus 16 comes how much? 18. But unit should be mentioned in what? U. What is U? Unified mass. Simple, understood? Right? Now see, second compound I am taking methane. So tell me what is the molecular mass for methane would have been asked. Atomic mass you have to know, carbon atomic mass is 12 plus each hydrogen is 1. 1 into 4, 4 into 1 I write. This comes how much? 16U. What is U? Unified mass. Now I take another compound, sulfuric acid. What is the formula of sulfuric acid? H2SO4. So how many hydrogens are there here? 2. So 2 into 1. Why? Because atomic mass of hydrogen is 1. Sulfur atomic mass is how much? 32. So 2 plus 32 plus each oxygen is 16. 16 fours are 64. Now when you add 64 plus 2, that is 66 plus 32, it will come 98. See, 98 in what units? U. What is U? Unified mass. So simple, understood. Same way I am taking glucose. What is the formula of glucose? C6H12O6. There are how many carbons here? 6 carbons, hydrogens 12, oxygen 6. What is the atomic mass of one carbon? 12. So 12 of 6. So you have to multiply this 6 with 12 plus hydrogen atomic mass is 1 plus oxygen 16 into 6. So 12 6 how much we get? 12 6 are 6. 72. 72 plus 12 plus 16 6 are 16 6 how much? 6 6 are 36, 96. When you add the total sum of all these elements, you get nearly 180. Check, is it coming 180 or not? This is the molecular mass of glucose. Same way I write here the fifth one, sucrose. What is the formula of sucrose? Sucrose, you know, no, it is called table sugar. So sucrose formula, it is a disaccharide. Its formula is C12H22O11. Now, in order to find the molecular mass of sucrose, there are how many carbons? 12. So 12 into 12 plus hydrogen 22 into 1 plus each oxygen is 16. 11 into 16. So that comes how much? 12 12s are, say 12 into 12 multiply, that comes 4 2 2 1 144. So this is 144 plus 22 plus 16 11s are. Multiply 16 with 11 in the rough work, 6161, that comes 176. So sum of all this comes nearly 342, you get, check. 342 in terms of what? U. So this is how we get algebraic sum. Simple, no? It is the algebraic sum of atomic mass of all the elements in a compound. But you have to be thorough with atomic masses, and I told you to stick periodic table in your hostel study rooms. So daily when you remember, if you remember these 20 elements only, you will able to go for mole concept. Copy this and we will find out for few more compounds. Completed, student. Now I write few more compounds. See, potassium permanganate. Do you know what is the formula of potassium permanganate? We write name potassium. It is an oxidizing agent. So what is the atomic mass for potassium? 39. Manganese in the previous class I told you to remember 55. Do you recollect manganese is 55 plus oxygen 16. 16 fours are 64. On adding this total you will get 158. Check 158 in what U. What is U? Unified mass. Same way you take potassium dichromate. What is the formula of potassium dichromate? K2Cr2O7. Now potassium, how many are there? 2 are there. 39 twos. 2 into 39 plus each chromium will have 52. 52 twos. 52 into 2 plus 16 sevens. On simplifying you get 298. Check, it comes 298 U. And you take next compound, ammonium sulfate. See, what is the formula of ammonium sulfate? NH4 taken twice SO4. Here, see students, be careful. Here nitrogen, how many are there? 2. So 14 into 2, 28 plus hydrogen you have to consider 8. 4 2s are 8 plus sulfur is how much? 32 plus 16 4, 64. So total when you add 28 plus 8 plus 32 plus 64, it comes 10, 18. 18 plus 4, 12, 22. This comes how much? 9, 10, 11, 132. This is coming 132 in what unit? U. And take last compound, copper sulfate pentahydrate. You know CuSO4 5H2O. This is called blue vitriol. What is the copper atomic mass? 63.5. This atomic mass 63.5 plus sulfur is 32 plus 16 fours are 64. Now see, once I am familiar, each water molecule 18. 18 fives are 18. When you multiply with 5, that comes 90. So understood, 1 mole water is weighing 80. So there are 5 moles of water. So 5 of 18 comes 90. When you add total of this, find out how much you get. Plus 64 plus 90. This comes 5. This is 5. 5 plus 3. 6 plus 3, 9. This is 15. 15 plus 6, 21. 249.5 you get. Check, is it coming 249.5 or not? Unit will be U. What is U? Unified mass. So this is what you have to be thorough with finding molar mass, because when we go into mole concept, you have to be thorough with all 20 elements. Along with 20, you have to be thorough with manganese, chromium. Sometimes they give ferrous sulfate. If I give you ferrous sulfate, what is the atomic mass for iron? 56. 56 plus 32 plus 64. That comes how much? 56 plus, add it in the rough work, plus 32 plus 64. This comes 12. 10. Is it coming 152? See, this is 10, 152. This will be 152 in what? U. What is U? Unified mass. Understood? No? Simple. This is how we find algebraic sum of atomic mass of all the elements in a compound. Copy it. Now we go for next, gram molecular mass. Till now what we learned? Atomic mass we learned, gram atomic mass we learned. Now I am going for gram molecular mass. Now copy next, right? Gram molecular mass. Now see student, just like gram atomic mass, we also call gram molecular mass, or this is also called simply gram mole. We also call it as gram mole, we say, or we even say molar mass. So these are the various names, student. Just like atomic mass, gram atomic mass we learned, no? So this is what we can call gram molecular mass or gram mole or molar mass, and we abbreviate with GMM. Okay. Now students, what is this gram molecular mass? You remember gram atomic mass, what we defined? mass of 1 mole of atom we defined, no? Or mass of atom expressed in grams we wrote. Same way here also, mass of molecule expressed in grams or mass of 1 mole of substance is called gram molecular mass. Understood? Right definition, mass of 1 mole of substance. Are you following, student? Mass of, just like gram atomic mass we wrote, no? Mass of 1 mole of an atom, here mass of 1 mole of substance. Or what we say, mass of molecule expressed in grams. Or what is another definition? Mass of molecule expressed in what? Grams. Clear. So you have to be careful. If examiner asks you what is the molar mass of water, my answer goes 18U. But if I ask you what is the gram molecular mass of water, what is your answer? 18 grams. Understood? So here, right, make a note, gram molecular mass for water. What is the gram molecular mass for water? If I ask you what is your answer? Instead of U, what we write? 18 grams. For water, I have to write 18 grams. Understood how I got this 18? This 18 is to be multiplied with 1.66 into 10 power minus 24. That is 1 AMU is these many grams, no? This is further multiplied with 6.023 into 10 power 23. That will give mass of 1 mole of compound, which is weighing how many grams? 18 grams. And if I ask you what is the gram molecular mass of methane, if I ask you only molar mass of methane, my answer go by 16U. Gram molecular mass of methane would have been asked, what should be the answer? 16 grams. Understood the difference between molecular mass and gram molecular mass? And keep it in mind, 1 gram molecular mass is equal to 1 mole. 1 gram molecular mass is equal to, they use this terminology in mole concept. 1 gram molecular mass is nothing but that is equal to 1 mole of substance. Clear, student? Now write next heading, formula mass. Right, formula mass. Now see, this is what is formula mass. Might be you studied in 10th standard. Compounds will be two types: ionic compound, covalent compound. Do you heard that in lower class? Ionic compound, for example, I take sodium chloride. You know, sodium chloride is an ionic compound. Getting idea what I'm saying? So ionic compound is formed by metal and non-metal. So you know sodium chloride in this, who is metal in 10th standard, you know, S block elements are present on extreme left side, no? So this is metal. Metal, what it does, lose electron. Non-metal, what it does, gain electron. So this is what compound, student? Ionic compound. So in ionic compound there will be two oppositely charged ions. One is cation, another is what? Anion. See, this is cation and this is what? Anion. Between at cation and anion there will be electrostatic force of attraction. So here point is, for whom we mention formula mass in exam they ask. Formula mass is mentioned only for ionic compounds, means having oppositely charged ions. Even you can apply any ionic compound, we can apply, but not for covalent compounds. So in exam point of view, they ask you for which of the compounds formula mass is applicable. So in the option you have to select where else the ionic compound is there, that you have to choose. Understood? Then what will be the formula mass? How I get formula mass of sodium chloride? Same as what we did in molar mass. That means algebraic sum. What is the atomic mass for sodium? Sodium atomic mass is 23. Atomic mass for chlorine is 35.5. So when you add both of these, how much it comes? 58.5. Unit will be same U. What is U? Unified mass. So here make a note. Formula mass is meant for ionic compounds. Only for ionic compounds having two oppositely charged ions. Understood? So formula mass for whom it is applicable in exam if they ask, in the option you have to choose ionic compound. Ionic compound like NaCl, KCl, K2SO4, Na2SO4, not for covalent compound. Understood? Simple. So how we get formula mass? We have to add the atomic mass of both the elements. So here sodium is 23, chlorine is 35.5. Adding both the atomic mass, it is coming 58.5. Unit will be in what? U. What is U? Unified mass. Clear up here. So till now, what else we studied? We studied atomic mass, average atomic mass, gram atomic mass, molecular mass, gram molecular mass, formula mass. These five terms understood everyone. So important it is. Atomic mass we learned. Atomic mass, recollect what I told, it is taken in reference to C12. Average atomic mass, generally what we take from periodic table is average atomic mass. And it is will have fractions I told you. There we find out abundance. And the third one we studied molecular mass. Fourth one we studied gram molecular mass. Saw the difference between gram molecular mass and molecular mass. And next we studied lastly formula mass. Clear? Now we go into mole concept. Right heading mole concept. So mole concept is very important, student, throughout the chemistry. Where else we go, mole concept will come in the questions. So right heading mole concept. This is very important in JEE mains as well as in NEET. Throughout the chemistry, we come across mole concept. Very simple. We have to understand the concept carefully. See, what is this mole concept? Simple it is, but you have to put in practice more of a simple. As you know, in daily life, we measure items, no? So, for example, 12 pens are there. We use what? A dozen. Same way, in chemistry, we measure what? Atoms, no? Atoms will be very large in number. So we measure the atoms in terms of what? A mole only, but we don't use a dozen like that. So this mole is meant for calculating the atoms as well as calculating the molecules in chemistry point of view. Then simple, what is this mole? Understand, say, chemists what they do, where what they did, chemists, they have taken carbon 12. You know, just now in the last class I told you atomic mass has taken with reference of C12 we learned, no? So here what they do, scientists, chemists what they did, they've taken carbon 12, C12 isotope. Are you getting point? C12. What is C12, students? Carbon 12 means I am using a word 1 gram atom. You understand the word? I am using 1 gram atom. Just now I told you gram atomic mass is also called gram atom. So 1 gram atom of C12 they took. So 1 gram atom C12 means students, can I say it is equal to 1 mole? So 1 gram atom of C12 is 1 mole, no? So what is the atomic mass of 1 gram atom of carbon? 12 grams, correct? So this 1 gram atom what they took, it is equal to 1 mole. Do you agree? 1 gram atom of carbon 12 is equal to 1 mole. In that 1 gram atom of C12, they found how many carbon atoms were present. In this 1 mole of carbon weighing 12 grams, what is the gram atomic mass of carbon? 12 grams, no? So in this 12 grams of carbon, how many atoms were present they found? So when they found C, they observed these many atoms. What is that number C? 6.023 into 10 power 23. These many number what they found? Carbon atoms they found. Understood? Simple. So in the 12 grams of carbon, C12, when they found the number of atoms, these many carbon atoms they found. And this number they called as a constant number. It is a constant number, and that number we are calling it as Avogadro number. So it's a constant number. This number we are calling it as what? Avogadro number. Up to this understood. Now coming to the definition of mole concept. See, I write the statement and make you to understand what is this mole. See, what we define, see, observe carefully. Amount of substance that contains the same number of elementary particles. I am using what? Elementary particles. See, understand the statement. Same number of elementary particles. Then what are those elementary particles? See, students, these elementary particles are nothing but this number. What is that number? 6.023 into 10 power 23. This can be, these elementary particles, what I am calling, it can be atoms, it can be molecules, it can be ions, it can be electrons, it can be protons, it can be neutrons, it can be, or even your name also. So what these elementary particles can be? It may be atoms, or it may be ions, or it may be molecules, or it may be fundamental particles. What are fundamental particles? Electron, it may be proton, it may be neutron. So understood, as were present in, where we found these students, 12 grams of what isotope? 12 grams of carbon 12 isotope. So this is the definition of mole concept. So, and I will make you better understand by giving illustration. The statement you understood, the amount of substance. What is the substance you take that which is having the same number of elementary particle? What is that elementary particle? 6.023 into 10 power 23 particles. That number we can be taken in terms of atoms. It can be, or it may be ions. It can be, or it may be molecules, or electron, proton, neutron, as were present in 12 grams of water, carbon 12. That is 1 mole. So 1 mole of any substance you take. Suppose 1 mole, I am taking 1 gram atom of nitrogen I take. What is the atomic mass for nitrogen? 14 grams. In that 14 grams, how many atoms will be there? Means what is your answer? This number we have to take. What is that number? 6.023 into 10 power 23 of nitrogen atoms. So this number can be either atoms we can take, or ions we can take, or molecules we can take, or electrons we can take, or protons we can take, or neutrons can we take. Understood? I make you better understand by giving illustration. So copy this statement. Understood? Are you following, student? So simple it is. I understand the concept. Simple what this mole concept says. In 1 mole of any substance, what is the 1 mole of any substance you take? In that there will be a constant number. That constant number we are calling it as Avogadro number, and this number is a constant, and that number is 6.023 into 10 power 23. And copy this statement for definition of mole. And this is very important, students, mole concept. And I told you daily you have to put in practice of 20 to 25 questions chemistry. So on the day what we teach, immediately you have to recap the concepts. And doubt is there, you have to interact with the teacher. After the completion of the lesson, you will be having doubt session like that. So the topic of what we explain here, you have to put in practice from PW study material as well as from NCERT. All of you buy NCERT textbook as well 11th class as well as from PW you have to solve the questions. And be regular for the classes and the interactive. You interact with the teacher, any doubt is there, clarify it on the same day. So that you will have what a fortnight test, you will have weekly test, you will have all India test series you have. So in that day one onwards, if you focus more, surely you will get good rank. So like that daily you make one goal or come join here with you have joined here with determination, no? So be regular for the classes and copy this. I make you better understand this. What is this illustration with example? What is mole concept? Are you following, students? So copy this. Done. Everyone copy this. Mole. What is mole? What is the definition? Amount of substance that contains the same number of elementary particles. This elementary particle will be 6.023 into 10 power 23 atoms, molecules, ions or fundamental particles as were present in 12 grams of C12. Now see students, I am taking 1 mole water. Tell me students, 1 mole water means, can I say gram molecular mass? 1 gram molecular mass is equal to 1 mole we discussed, no? So tell me what will be the mass for 1 mole of water? If I ask you what is the gram molecular mass of water, what is your answer? 18 grams, correct? So how we got 18? Algebraic sum. Now in this 18 grams of water, my question is how many molecules will be present? In this 18 grams of water, what will be the number of molecules? That number will be same as in 12 grams of C12, no? So what should I write here? 6.023 into 10 raised to 23 of what they are? Molecules. Understood, students? Simple, no? So in 1 mole of water, what is the 1 mole substance you take? In that Avogadro number of particles will be there. So this is in terms of molecules. Clear? Are you following? Now see, I am taking same 1 mole of water. Now in this 1 mole of water, how many grams it will weigh? Means what is your answer? 18 grams, correct? So in this 18 grams, my question is now, how many atoms are present? How many atoms? Means you know atomicity. What is meant by atomicity? Number of atoms present in the 1 mole. Now can you tell me what is the atomicity here? 2 from hydrogen, 1 from oxygen. Since he is asking atoms, you have to consider the total atoms. Total atoms are how many? 3. So what should I do? This 1 mole of 18 grams water is having 3 atoms, no? So I have to write this as 3 into, sometimes in textbooks they write like this. Avogadro number is mentioned as what? Na. These many what they are, students? Atoms. See, with respect to atoms it will be. Now the same, are you following? So here atoms is asking, so total 3 atoms, that's the reason we multiplied with 3 into Avogadro. Now see student, I am taking the same 1 mole of water. Now in this 1 mole of water which is weighing 18 grams, how many oxygen atoms are there? So you have to be careful. If total atoms would have been asked, my answer go by 3. Now I am asking only of what atom? Oxygen. Now how many oxygen atoms are there in 1 mole of water? 1. So now I have to consider 1 into Avogadro number of what atoms? Oxygen atoms. Getting idea? So if total atoms would have been asked, 3 I say. But only oxygen atom is asking. So here there is only 1 oxygen. I wrote 1 into Avogadro. Now the same 1 mole of water I am taking here. This 1 mole of water which is weighing 18 grams. Now my question is how many hydrogen atoms are present? So previously oxygen we asked. So here 1. Here how many hydrogen are there? 2. So what should be answer? 2 of Avogadro number of what atoms? Hydrogen atoms. Understood? So you have to be careful in exam whether examiner is asking total atoms or confined to particular atom. Understood? Now see, I am taking the same 1 mole of water. So this 1 mole of water which is weighing 18 gram, in this how many electrons will be present? In the last class we found how to find number of electrons. Do you remember from hydrogen 1 into 2, 2, 2 plus oxygen 8. There are 10 electrons. So what should I write? 10 into Avogadro number of what they are? Electrons. Understood? If examiner asks you electron, I have to take in terms of electron. Now the same 1 mole of water I am taking, which is weighing how many grams? 18 grams. Now in this 18 gram, how many protons will be there? So protons would have been asked. You remember in a neutral atom we discussed how many electrons will be there, same number of protons will be there. So here also answer comes what? 10 into Avogadro number of what? Protons. P means proton. Now I am taking the same 1 mole of water which is weighing how many gram? 18 gram. In this 1 mole of water which is weighing 18 gram, how many neutrons will be there? So if neutrons would have been asked, see we have to be careful. Hydrogen doesn't have any neutron, no? Because mass number minus atomic number comes 0. So only from water, oxygen I have to take 16 minus 8. So what should be the number? 8 of Avogadro number of neutrons. Hence we can say, see, mole can be applicable to molecules, atoms, or even what fundamental particles like electron, proton, neutron. So simple, no? Copy this. So what is the substance of 1 mole you take? In that 1 mole, it will have that many number of particles as they present in carbon 12. And that number we are calling it as Avogadro number. So understood students, all of you, what is mole? Simple, no? So 1 mole of any substance contains Avogadro number of particles. It may be atoms, ions, protons, electrons, neutrons, any particles we can take for 1 mole. Copied all of this. So today we conclude here. Tomorrow we work few numericals on mole concept. And while coming tomorrow's class, once read the concepts till now what we completed. Understood students? So I'm ending the session. Wish you all the best. Bye.